Okay, I've got an exercise to help the appraisers, help prepare them for their formal training. Our appraisers are expected to take the fundamentals for appraisers by the DPA and State Board, and also there's the IAAO course 101 that is the fundamentals of appraisal. So what I'm going to try to do with this is to help you remember the math skills that you probably learned years ago, whether it was college, high school, junior high, but kind of get you working to thinking about that. We'll progress with various training exercises that hopefully will help you with that, and certainly help you with the math that you're going to have to perform in those two courses. All right, so first we're going to start off, and what we're going to look at is percentages and ratios, because those are used quite often by appraisers, and they're used in all three approaches to value. They're used for land valuation. We may be talking about capitalization rates in the income approach. We may be looking at depreciation in the cost approach, using that in other places as well, or percent good. We may be looking at the 5 different ways to value land. And these math skills are going to be important to you in order to successfully meet the criteria for the exam. So in looking at that, I'm using these 5 circles. There's 12 actually. There's 12 of these, and I have them colored blue and yellow. And we're going to be looking at those and developing ratios and percentages to start off with. So here are these 12. We got 1 yellow, and the question is, what percent are yellow? Now the rule of thumb on this is, in working all of these exercises, is that you'll take the part, and that's the yellow here, less than the whole, and we're going to divide it by the whole. Some people tend to want to take the 1 yellow one divided by the number of blue ones, but that's not giving you a true percentage. Yes, there's 1 out of 12 that is yellow, or there is 11 out of 12 that's blue. But we won't take those numbers and relate them to the overall population of the whole. Like in depreciation, when appraisers work with depreciation, they're looking at so much depreciation per year, and they are going to take that and apply that to the number of years that the property has aged, using that effective age, and they'll apply it to 100% of the replacement cost new. So we're kind of preparing for working with these numbers, with these math functions, for that purpose. So here we got 1 out of the whole group, 100% being 12, and we want to solve for the answer. And to do that, we're going to take 1 yellow and divide it by 12 total, which yields us 8.3% or 0.083. And notice we can express that percentage 2 ways. We can express it as we normally say, 8.3%, or we can write it numerically, where it's a decimal equivalent, and there we move the decimal places. We're dividing 8.3 by 100, so that means that you're going to move the decimal place over 2 points, or you put in your calculator. You can put 8.3 and divide it by 100, and you will get this number over here, 0.083. Now don't let the leading zero cause you confusion. I've seen it cause people confusion. The calculator you're using always places a 0 before the decimal point to alert the user that you're working with a number that's less than 1. On whole numbers 1 or greater, it never puts that leading 0 there, but it is here, and I've seen students have difficulty with this. And when they try to take that and use it in the problem, they will quite often put an extra 0 in there. They'll say 0.0083. They won't read it as 0.083, which is just 8.3%. So try not to make that mistake. It will cost you on an exam, possibly. So solving for this problem. We've just seen you take the part and divide it by the whole population, 1 divided by 12. Now let's look at the numbers that are blue. Here we have 11, blue, total population again, 12, so we take the part, the 11, divided by the whole population of 12. And in doing that, we're going to get this number. 11 divided by 12 equals 91.7%, or 0.917. Or if I was just looking at that, I could say just 91.7%, have it understood in my mind that I'm moving the decimal point. I'm multiplying 0.917 times 100 and move the decimal point 2 places to the right and add a percent sign, 91.7%. I could have also, when I was up here with the one yellow egg and knew that it was 8.3%, I could have solved for the percent that were blue at that time just by taking 100%, that's full, that's complete, that's the whole population, and subtracting 8.3%, the yellow portion, which would leave me 91.7%. Or if I was over here, I'd write it 1.000, then I would subtract 0.083 from that. Again, would be 0.917. Same thing with the blue. If I did it first, I want to know percent that was yellow. I would just subtract 91.7 from 100%, and that would give me 8.3%, or 1.00 minus 0.917, which would again give me 0.083. Again, don't let that leading zero mess you up. Looking at it like it was depreciation, if this yellow egg represented one time frame, one span, 1 year of depreciation, if you want to depreciate that 1 year, had 12 total years, it would get 8.3% depreciation. So your replacement cost new is the 100%, and you would multiply that times that amount. If it was $100,000 and it was going to depreciate 8.3%, you multiply 100,000 times 8.3%, it would be $8,300 depreciation, leaving you a percent good of 91.7%, or $91,700. And again, you could, as far as saying what is percent depreciated, or what is the percent of the property that is still there, you could say it was $91,700 because you multiplied 0.917 times 100,000, and that's how much is left, has not depreciated. All right, I hope that helps. One more. Let's do the blue and yellow before our time runs out. Got to limit these to less than 10 minutes. And here it asks what percent are yellow. You can see half of them are yellow. Six. I've already answered my question. Half. What is half? Half is 50%. 50% are yellow, 50% are blue. The total of them together is 100%. But if we do the math, we'll go ahead and do the math. 6 divided by 12 equals 50%, or 0.50. And I can say the same thing for the blues. You work it the same way. They would be 6 divided by 12 also for that. So I'm going to end this session here. It's my first one, and want to try to get it uploaded to YouTube or Facebook one, and be on the watch for others following this one.